Hello everyone, welcome to this video. In this video we are going to study about equivalence relations. Now first of all, why do we require to study these equivalence relations? Before understanding what are they? So let's answer this question, because in certain instances we wanted to make distinctions and we wanted to define the equality of two different objects and things very precisely. So that is why equivalence relations are required, right? For example, you could understand this thing from this example that whenever you wanted to add 2 plus 1, that give you 3, right? And when you wanted to add 4 plus 4, that give you 8. So in ordinary addition they are not exactly equal to each other. One is 3 and one is 8. However, they are equal to each other when you take the addition under modulo 5. Now what does that mean? That means that when you add up 2 plus 1, that give you 3. So 3 modulo 5, that is equivalent to 3, right? And when you wanted to calculate 4 plus 4 modulo 5, so that is 8 modulo 5, and when you calculate 8 modulo 5, it again come out to be 3, right? Why? Because you can write 8 as 5 times of 1 plus 3, so 3 is the answer here. So using this thing here, they are same. So how can you say they are same or they are not same or they are equivalent to each other or not? So that is why equivalence relations are required. For another example is that if you have congruent triangles which are situated on different planes, they are different to each other, right? But whenever they are considered in plane geometry, they are considered to be the same because of the congruency of different triangles. So this is the differences. The same thing appear to be same in one place and different to be at the another place. Let's see another example about vectors. Suppose we have vectors of same magnitude and direction. Now those vectors, they could also be taken as same as in linear algebra. We take the vectors with same magnitude and same direction as the same vectors. However, they could also vary according to the positions. For example, their effects could also be different. For example, suppose we have a 10 kg weight, right? If that is placed on a table, its direction is obviously downwards and the weight is also fixed, that is 10. Now the same weight would have a different effect when we place it on a shorter table, and it would have a different effect when we place it on a higher table. So you see their effect and force would vary according to their positions. So here in this case, same magnitude and same direction would give you different results. However, in linear algebra we take them to be the same. So you see the difference. So if in order to answer these questions, we have this term which is the equivalence relation. Now what is this equivalence relation and how do we mathematically define it? So let's move on to this. So here an equivalence relation, it is defined on a certain set. Let's call that set to be S, right? And it is a relation of ordered paired of elements S. So that means from S you take two elements and you make them into a tuple, say A and B. Then we need to check that for this tuple of ordered pair of elements, the following properties they should hold in order for this R to be an equivalence relation, right? So let's see what those properties are. The first property here is of reflexive property. Now what is this property? This property say that the element should be related to itself. So suppose we take some element A from S, then A should be related with each other. So that means A should be related to A, right? This is the property here. It is reflexivity, that it should be related to itself. The second property is of symmetric property. Now this property tell you that if one thing is related to another, then another one also has to be related to the first one. So it tell you that if A is related to B, then B also has to be related to A. If both of them happen together, then symmetric property holds, right? Next property is transitivity. Now under this property, what do we assume? That we assume that A is related to B, and then we also assume that B is related to C. Now you see a link. we have A related to B and B is related to C. Now we are according to this property, if it is transitive, right, then this A would be related to C also. So A is related to C also. So these are the three properties by which you form an equivalence relation, right? So you should note certain things here, that sometimes instead of this notation that an ordered pair A comma B belongs to R is the given relation, we also write A capital R B, which is same as saying that A is related to B, right? And moreover, sometimes we use the symbol this one, or this one to denote equivalence relation, right? So they are the common symbols that are used in order to denote this equivalence relations, right? This is an equivalence relation on a set S. Now the third thing, now this is an important thing, we are now talking about equivalence class. So understand this thing very carefully, that what is an equivalence class. So what is an equivalence class? Suppose this equivalence class is defined for a certain element or member, which is, I am calling that to be A, which is taken from the initial set S. So that means we have this set here, we take one certain element from it, we call it A. Now according to this element we would have a class to it, and that class would contain all those members, all those elements which are related to this particular element A. So this is the meaning. So we denote it by the letter whose class we are making, and by the square brackets like this, and this class would contain all such members of the given set which are related with this particular element A. So this particular element is fixed, and we are calling that it is the equivalent class of A, right? And so that means for this particular set there would be many such equivalent classes, right? So for different elements we would have different equivalent classes, and each one would contain elements which are related to them, right? So this is what we have about equivalence relations and equivalence classes. We'll be studying more about it in the next video.